So if you've watched our first video about measures of central tendency and how to interpret that, you know the data we're working with. So now let's look at these measures of dispersion, right? Because dispersion tells us how the data spreads out from that central tendency, that central point. So if we start with our central point of the mean, we know that that is sensitive to outliers. And we're going to actually skip down to the lowest on this chart type of measure of dispersion, standard deviation. That is associated with the mean. So the standard deviation is the basically standardized distance from the average score. So it's a measure that we can use to compare different distributions to see how different distributions fall with respect to their mean. That's why it's so helpful here, because we have two distributions, Democrats and Republicans. So we know that Democrat standard deviation is 17.3, whereas Republican standard deviation is 13.5. So we can compare this and say that Democrats have more dispersion around the mean. They are more spread out than Republicans. Now, for some types of distributions, this will be an even more powerful tool. If we had a standard normal distribution, which to an extent the Republicans are standard normal distribution because the median and the mode are the same. Ideally, for standard normal distribution, the mean would coincide with them as well. I apologize, I keep saying standard normal. It can just be a normal distribution. It doesn't have to be standard. So for a normal distribution, the mean, median, and mode would all be the same. But we can see that this approximates a normal distribution. So we would know that within two standard deviations of that mean are about 95% of Republicans. So about 95% of Republicans will vote between, in this case, we can't go two standard deviations from the mean, lower than that because the lowest score is 0. So between 0 and about 26 points higher than 14. So about 40, right? So about 95% of Republicans will have a vote between 0 and 40. And we know this from just looking at the mean and the standard deviation. Now, again, that's only because the Republicans seem to approximate a normal distribution. The Democrats do not, right? The mean, the median, and the mode are not close. There's a big spread, almost 10-point difference between the mean and the mode. So we know that's not a normal distribution. Makes the standard deviation maybe a little less helpful for us, but we still know that it's a good comparison between the Democrats and the Republicans. Now, one big problem with the standard deviation is that it, like the mean, is sensitive to outliers, right? Because we are actually calculating the standard deviation using a square of the average distance from the mean. That means that if we have a couple weird values, right, a couple outliers, that's going to really pull things. So sometimes it's more helpful to look at the range and the interquartile range. Now, the range is, depending on how you calculate it, not very sensitive to outliers. The range, however, can just be calculated using the maximum score minus the minimum score. So that gets us a measure that would actually be extremely affected by outliers. What we often do to avoid that is use a calculation to determine what numbers are our outliers, what values we have in our data that are outliers, chop those off, and then calculate the range without them. In that case, obviously, the range is not remotely sensitive to outliers. However, in this case, I did calculate it without bothering to discard outliers. So in this case, it is somewhat affected by the outliers. But for my purposes, I do want to see the full range. I want to consider those outliers because they're interesting to me in my analysis. why are they so different from their party is going to be something I want to look at. So I didn't want to discard them from this quantitative analysis. And we can see that the Democrats have a wider range than the Republicans. Just like I was saying when we were starting to interpret central tendency, that those numbers not aligning, those measures of central tendency not aligning, indicates there's probably going to be a lot of spread. And we now see that for sure. The range is nearly 10 points wider, right? Now, for the next measure, interquartile range, that one's really convenient. It measures the difference between the 25th percentile and the 75th percentile. Right? So it's basically measuring the middle 50% of our data, centered around the median. Just like the median is not sensitive to outliers, the interquartile range is not sensitive to outliers. And this tells us the bulk of our data, right? Half of our data is within that interquartile range. So it can allow us to say how sort of clumped the data is, but still allow for the fact that we know 25% of the data is going to be dispersed lower, 25% of the data is going to be dispersed higher. And we can still see that for the Democrats, our interquartile range is larger than for our Republicans. The difference is not as dramatic, but it is still there. So with any measure of central tendency, the Democrats just have more variation from our measure of central tendency than the Republicans do. And this, as I said before, fits nicely with trends. We would expect that Republicans would generally be towing the party line better than Democrats. And that seems to be the case. So if we define polarization, remember we operationalized polarization earlier this semester as both increased partisan difference. So each party moves further from the other party, but becomes more concentrated around their party average. So for this, we can't see if the party means, medians, or modes, right? I'm using average, but we don't know which measure of central tendency I'm intending to use. In this case, I am using average to mean. But if the party means move apart, we would have to do this calculation for several different points in time, right? And then we can see if the party means move apart and our maybe standard deviations shrink. Now, because of those couple outliers, those couple unusual votes, and the fact that the Democrats seem very, very clumped, except for that one outlier, it may make more sense for me to use the median and the interquartile range, because those are going to be less sensitive to outliers, and calculate that over time rather than our mean and our standard deviation. So we can see that picking the right measurement is important depending on what we're measuring and if we know our data set is going to have outliers or not. And then we can interpret the information accordingly and use it to start answering our research questions. So in this case, my research question was sort of how, is Congress polarized on issues of climate change? My answer would be yes, right? Yes, they are. There's a major difference between any of the measures of central tendency. And that difference is even more extreme when you are using outlier resistant measurements. And even if you look at standard deviation, which again is affected by our outliers, we can see that the majority of our votes are going to be off to the side. There's dispersion, but not a ton of overlap. We can tell that especially from things like the interquartile range. 50% of our Democratic data, 50%, sorry, of our Democratic votes are within 12 points of our median. So we can't go 12 points up because we stop at 100. So between 100 and 82-ish, there's a 0.3, but 82. Whereas our Republicans are within about 9 points, let's round up there, of our median, which is 12. So Republicans go from 3 to 21. So we can see there's a massive amount of daylight between the interquartile ranges of each party. So that is something that might be really useful to visualize. You can see I'm already holding up my hands to start to like picture that. So next class, we will be talking about how to picture this, how to visualize these things. So that is brief introduction to interpreting our measures of dispersion. If you haven't looked at our measures of central tendency, you can go back to that video now.